All right, so we're continuing on today with lesson 10. So we're adding mixed numbers. And last time we used the models to do it. And sometimes the models help people and sometimes the models help or mess people up. It just kind of depends. But really all we need to do today for our notes, sorry, I'm mixing it up everywhere. All we need to do is just give you some examples, okay? So you have your note paper here, but we're not going to use it for actual notes like we do, like we do over here that we did in the past. We're just going to put examples here. Some examples will be easy, some examples will be hard. So we'll start first. And there's a couple different ways you can do this. You can lay out your problems this way so that they're horizontal. You can also lay your problems out vertically. I'm going to show you both ways, and you can decide which one you want. I suggest vertically, one on top of the other, just because when we get to bigger numbers, it'll be a little easier. But like I said, we'll try them both ways. When you have matching denominators, and you don't have to change the denominators, horizontal is easy. It's no big deal. When you have to change the denominators, it gets a little bit harder. So that's why I'm saying to do it this way. Also, when we start to borrow, when we're subtracting and we have to borrow, vertically is definitely easier. All right, so we have two matching denominators here. These are both 10s, so we don't have to do anything there. So I always start with adding the fractions. And since these are 10, we don't have to do anything there, but we can do numerators. 1 plus 7 is 8, and we slide the denominator over just like before. Then we move into the whole number part. So 2 plus 5 is 7. So 7 and 8/10 is almost done because we can simplify this so it's not done. We'll go ahead and look at these numbers. I think they can both be divided by 2, and that's the greatest number they can be divided by. So we'll move over our 7 as the whole number. 8 divided by 2 is 4. 10 divided by 2 is 5. And that one is done. So that one was pretty easy, right? Okay, let's look at another one. This one has matching denominators again. So I'll go ahead and just leave this one horizontal one more time. So 9 and 3/4 plus 8 and 3/4. Okay, and I look at this and I go, oh, matching denominators, great. So I'll do 3 plus 3 is 6 over, slide that denominator over, that's a 4. Okay, now I have an improper fraction here, so I know I'm going to have to do some work, but that's okay. I can leave it for now. Excuse me, 9 plus 8 is 17. So far I have 17 and 6/4. Okay, when you have a greater numerator than a denominator, you have to give, that means you have a whole number in here. So you're going to give one of your wholes, like it's like carrying in regular addition. You're going to give one of these wholes over here. So that means I'm going to have 18 because 17 plus one of these wholes is 18. And then I say 6 minus 4 is 2. And again, you slide the denominator over. But of course, we're not done again because these can be simplified. So 2 can go into 2 once. 2 can go into 4 twice. So we have 18 and a half as our answer there. Okay. And now we'll get to a little bit of a harder one. So I'm going to go ahead and turn this one vertically and get you a little closer. So we have 3 and 5/8 plus 6 and 1/2. Okay. And I make this line a little longer than it needs to be because I know I'm going to have to make some new fractions over here. So 8 is the greater numerator and 2 can go into 8. So let's just use 8. So I'm going to go ahead and move this over here. So this is now like my new fraction area over here. This is my new mixed number area. And I know that this is going to be my new denominator, 8. So now we go 8 divided by 2 is 4 times 1 is 4. And the 6 moves over. So now here's my new problem. Okay. And this helps me to visualize that this is no longer here. Now I'm working here. Then I'm adding again, same denominators. So I say 5 plus 4 is 9 over 8. 3 plus 6 is 9. So I have 9 and 9/8. But again, this is an improper fraction because it's too big on the top. So one of the whole numbers is going to come over here, which makes this 10. Then you say 9 minus 8 is 1. And slide your denominator over. It's 1/8. So now you have 10 and 1/8. Okay, so that's not too hard because we know how to change those denominators. We did that all last week, right? All right, let's try another one. We have 1 and 1/12 plus, I'm going to go vertical again just because I prefer this method, 4 and 5/12. This one doesn't look like it's going to be that bad. Matching denominators, great. So now 1 plus 5 is 6/12. 1 plus 4 is 5. But 6/12 can definitely be simplified. 6 can go into both of these numbers. So 6 goes into 6 once. 6 goes into 12 twice. So that's my number there. So that's a nice, good one, a nice, easy one. I'm looking for another one that I think could be pretty easy. So I can fit it in this hole is what I'm saying. Let's try this one. I don't know if we're going to have enough room, but I'm going to try it. We'll go vertically. 9 1/2 plus 12 and 11/20. Okay, and again, I make the line long because I know I'm going to have a different denominator. But 2 will go into 20, so let's leave that one. So again, I'm going to move the one that was perfectly fine just over here, so I know it's ready to roll. This one I'm going to change into 20. 20 divided by 2 is 10. 10 times 1 is 10. So I have 9 and 10/20. Okay, so now I'm ready to add. So, get a bit of pencil here. All right, now I have matching denominators. So I say, okay, well, 10 plus 11 is 21 over 20, because again, the denominator just shifts down. 9 and 12 is 21. So 21 and 21/20. That's kind of hard to say. We're going to have to simplify that because this is greater than this. The numerator is greater than the denominator. So he's going to give one of his wholes over here. He'll become 22. 21 minus 20 is 1 over 20. So my answer is now 22 and 1/20. Okay. Let's try one more of the more difficult ones, just so you're set up for success when you guys start. And I'm going to do 11 and 3/5. 11 and 3/5 plus 6 and 4/15. Okay, again, matching, they don't match. Denominators don't match. I feel like it's hard to see this. Okay, and since the denominators don't match, we're going to make them match. So 5 will go into 15, so let's use that. So we now have 6 and 4/15. And we'll change that one into 15 too. 15 divided by 5 is 3, times 3 is 9. So now we have 11 and 9/15. Okay, here we go. 9 plus 4 is 13/15. 11 plus 6 is 17. So now we have 17 and 13/15. Now, since 13 is a prime number and this isn't like 26 or a multiple of 13, we know that this is done. So it's a lot of steps. It's not hard because it's something we worked on, but a lot of steps you got to remember. Let us know if we can help you.